Before fiber and 4G became widespread, engineers developed wireless broadband alternatives. MMDS, multi-channel, multi-point distribution services, was essentially cableless television. It operated in the 2.5 to 2.7 GHz band with an omnidirectional antenna reaching about 50 kilometers, delivering TV channels over wireless microwave links. LMDS, local multipoint distribution services, operated at much higher frequencies, 24 to 38 GHz, providing wireless broadband at up to 622 megabits per second, but only within about 5 kilometers. LMDS used either TDD, time division duplexing, where transmitter and receiver take turns, or FDD, frequency division duplexing, where uplink and downlink use separate frequency bands. Multiple access was achieved through FDMA, where users are separated by frequency, or TDMA, where users are separated in time. It is important to note that both MMDS and LMDS have been largely replaced today by cable, satellite TV, fiber to the home, and 4G or 5G fixed wireless access. However, the principles of TDD, FDD, FDMA, and TDMA that they introduced remain fundamental in modern cellular networks. Wireless Local Loop, or WLL, aimed to replace the copper wire in the last mile with a wireless connection. WLL systems used CDMA, code division multiple access, and could cover areas with a diameter greater than 15 kilometers. The original WLL supported data rates of 56 to 128 kilobits per second. Today, this concept has evolved into 5G fixed wireless access, or FWA, which delivers gigabit speeds wirelessly to homes and businesses. Both WLL and modern WLAN rely on a technique called spread spectrum. In spread spectrum, the signal is deliberately spread over a bandwidth much wider than necessary. This provides reliability, security, and resistance to interference. There are two main types. Direct sequence spread spectrum, DSSS, replaces each data bit with a longer code called a chip sequence. The receiver uses the same code to extract the original data. To an unintended receiver, DSSS looks like low-power background noise. Frequency hopping spread spectrum, FH-SS, rapidly switches the carrier frequency in a pattern known only to the transmitter and receiver. FH-SS is used in Bluetooth, as we will see shortly. Wireless LAN, or WLAN, provides network connectivity without cables. The original standards from the early 2000s operated at 2.4 GHz and 5 GHz with data rates of 11 to 54 megabits per second. The technology has advanced dramatically since then. Wi-Fi 4, based on 802.11n, introduced MIMO and reached 600 megabits per second. Wi-Fi 5, 802.11ac, pushed speeds to over 3 gigabits per second. Wi-Fi 6, 802.11ax, supports up to 9.6 gigabits per second with better performance in crowded environments through FDMA. And the latest Wi-Fi 7, 802.11be, targets speeds up to 46 gigabits per second using 320 MHz channels and the new 6 GHz band. Despite these massive speed increases, the fundamental spread spectrum principles remain at the core. Bluetooth is another short-range wireless technology operating at 2.4 GHz using frequency hopping spread spectrum. It hops between 79 channels 1600 times per second. Originally designed for cable replacement at 1 megabit per second, Bluetooth has evolved through version 5.0 and beyond to support speeds up to 2 megabits per second, ranges up to 400 meters, and low-energy modes for IoT devices like fitness trackers and sensors. Let us review. MMDS and LMDS were early wireless broadband technologies, now largely replaced by fiber and cellular, but they introduced key concepts: TDD, FDD, FDMA, and TDMA that are fundamental in today's cellular networks. Wireless local loop evolved from 128 kilobits per second into modern 5G fixed wireless access at gigabit speeds. Spread spectrum techniques, DSSS and FH-SS, provide reliability, security, and interference resistance. Wi-Fi has grown from 54 megabits per second to Wi-Fi 7 at 46 gigabits per second, while maintaining spread spectrum fundamentals. Bluetooth uses FH-SS at 2.4 GHz for short-range wireless and now supports IoT with Bluetooth Low Energy. In the next lesson, we will explore satellite communications, GEO, LEO, and MEO orbits, transponders, and VSAT systems.